Hi everyone. In this video, we're going to talk about another test called the root test. It's going to look a lot like the ratio test, but slightly different. The only difference is that instead of computing the limit of a ratio, we compute the limit as n goes to infinity of the nth root of the absolute value of an. From here, the three cases are exactly the same. If the limit is less than 1, then the series converges absolutely. If the limit is greater than 1, or goes off to infinity, then the series diverges. And if the limit is equal to 1, then the root test is inconclusive. Now, as you may have guessed, the root test works well when we have something raised to the nth power. For example, let's try to use it on the sum from n equals 1 to infinity of minus 1 to the n times 2n over n plus 1 all raised to the nth power. Taking the limit, we find that the minus 1 goes away because of the absolute value, and then the nth root cancels with the nth power. And we're left with the limit of 2n over n plus 1, which goes to 2. And since this is bigger than 1, we find that the series diverges by the root test. Next, let's take a look at the sum from n equals 1 to infinity of n over 2n plus 1, all raised to the nth power. Taking the limit, we see that the n's cancel, and so we're left with the limit of n over 2n plus 1, which goes to a half. This is less than 1, and so the series converges absolutely by the root test. Finally, consider the sum from n equals 1 to infinity of natural log of n over n all raised to the nth power. We take the limit and simplify to get the limit of natural log of n over n. We see that both the numerator and the denominator go off to infinity, and so we can use L'Hopital's rule. The derivative of the top is 1 over n, and the derivative of the bottom is 1. And so we get the limit of 1 over n, which goes to 0. And since this is less than 1, the series converges absolutely by the root test.